ladies and gentlemen. With this first presentation, we want a bit to set the scene also for the following two presentations, saying or answering the questions, what are the main drivers for defossilization of medium-speed engines? Why is defossilization also expected to become this relevant in the future? What are the key challenges being related to that? And also to answer the question, what are also according opportunities? Yeah, talking about drivers for defossilization, I think one of the overarching drivers for this is the overall CO2 reduction targets, which have been defined more or less by all of the key market areas worldwide. So if we look to the left-hand side of that slide, I think in average, there is a target of about 50% CO2 reduction until 2030. And for the majority of the markets, also the target to become CO2 neutral, at least until 2050 timeframe. Some of these markets, even with more ambitious targets, like for example, Germany, also UK, some of the markets with a less ambitious targets, like for example, India. But again, in average, I think overall quite ambitious targets here. And one of the key messages we also want to give with that slide, in order to achieve these challenging CO2 reduction targets on a worldwide perspective, there needs to be according contribution from all of the industries in order to achieve these targets. And if we consider the medium speed segment, I think the relevant industries, they also are significantly contributor to the overall worldwide CO2 emissions. So if we have a look to the left-hand side here of that slide, shipping being related to about 3% of overall CO2 emissions worldwide. If we just relate that to the transport sector, so this is a larger gray segment here of that chart, this will even be about 10% of the CO2 emissions from the transport sector being related to shipping. We also have according contribution here for rail and another important segment also for the medium speed engines, the electricity and heat generation, the power generation, which also would be included in that part here. And due to that fact, also already quite several initiatives have been started in order to address these CO2 reduction challenges. If, for example, we look to the marine, we have the IMO greenhouse gas reduction targets minus 50% until 2050, and to become even CO2 neutral latest until 2100. There is also a so-called Getting to Zero coalition, which is targeting for commercially viable deep sea vessels with zero CO2 fuels until 2030. So additional driver also here for defossilization in the marine sector. And considering the generator set market, also here a strong push from the market, from the customers. There is on the one hand the cost pressure from the CO2 permit prices, and also more and more customers, they are also demanding for climate neutral fuels here, demanding for green energy. And in a similar way, also for the rail and mining industry, which with regard to medium speed engine maybe is not that significant. Let's have a bit closer look to shipping in the first step. So if we have a look on regulations which are already defined in the marine sector, on the one hand, we have the emission regulations, the IMO regulation for the worldwide shipping. We have also local regulations in force, like the European Stage 5 regulation or the Tier 4 regulation in the US market. In addition to that, also in order to address CO2 emissions, there is also already various measures being enforced. On the one hand, we have that so-called Energy Efficiency Design Index, which is defining targets for the CO2 emissions which are emitted per unit of transport work, and which in particular is also addressing the fuel consumption of main but also auxiliary engines. In addition to that, we have the Ship Energy Efficiency Management Plan, which is mainly addressing the operation of the vessels on the ocean. So this is addressing fleet efficiency and also the management of the ships. And in addition to that, as already mentioned before, we also have, according short, mid, and long-term greenhouse gas reduction targets, being defined by the IMO, being defined here. And in addition to that, what I think we also have to assume becoming more and more also relevant in the future is additional local requirements. Specific markets, maybe even some specific city areas also defining according targets with regard to CO2 emissions in order to fulfill their individual CO2 reduction targets. So how does that look like on the timeline? So on the one hand, or on the first step, starting here, with EEDI, SEMP regulation. So this regulation also already being in force for some time. Also the next phases already being defined. And in addition to that, we also have the IMO CO2 reduction targets, as mentioned before, with the target minus 50% global greenhouse gas emissions from shipping until 2050. 2100 latest also to be greenhouse gas neutral here. And very important, and we will come back to that also later on in the presentation, this is not related to new vessels being launched into the market. This is related to the entire fleet being operated on the oceans. And this is in particular also what is also important that the baseline here is the 2010 greenhouse gas emissions. So also any further increase of the transport, the marine transport here will also be directly related to additional challenge in order to achieve these greenhouse gas reduction targets. And in addition to that, as also already mentioned on one of the previous slides, we also have voluntary targets, like that getting to zero coalition. So that means large fleet operators, which also defined according targets, which are even more ambitious, compared to the targets which are defined by IMO. With this slide here, on the one hand, on the left-hand side, showing a projection of the global shipping demand, and this is also related to the aspect I already mentioned before. So with regard to global shipping, the assumption is that there will be also a significant increase, with regard to transport in the marine sector, ton kilometers by shipping, and this at the end also adds significant additional challenge to the CO2 reduction targets. So as mentioned before, the baseline for the IMO greenhouse gas regulation is the 2010 time frame, and the reduction targets are defined based on this 2010 CO2 emissions from the marine sector. And on the right-hand side here, this is showing an estimate what can be achieved with the already defined EEDI SEMP measures. And if we relate that to the 50% greenhouse gas reduction target in 2050, the key message here, there's a huge gap remaining. A huge gap of about 70% of the greenhouse gas reduction which needs to be achieved, where we need additional measures in order to comply with that. So that means new technologies, in particular, also including alternative fuels, most probably will be needed in order to achieve these challenging CO2 reduction targets. But, and I think this is also quite important, it's not just the regulation which is pushing for low CO2, low greenhouse gas solutions in the future. It's also additional drivers. It's on the one hand, green sustainability targets also by the customers, the big fleet operators, which in the future will also more and more ask for that. It's also the public pressure, which also in general puts a lot of pressure on CO2 greenhouse gas reduction in the transport sector. And also the life cycle assessment, for consumer goods, which also puts quite a lot of pressure on a overall sustainable value chain, also including the transport also in the marine sector, for example. So what are possible solutions in order to address these challenges? And I think here we have quite a huge spread also of technology options available in order to further improve the medium speed engine powertrains in the future with regard to CO2, but also pollutant emissions. So on the one hand, we have the engine optimization, we have hybridization, we have different alternative fuel options, we have the battery electric solutions, we have fuel cell solutions, and so on. And not going into all of the details with regard to CO2 reduction potential, but also with regard to the potential to reduce pollutant emissions to even achieve zero CO2 or zero pollutant powertrains, there are some differences between the individual solutions here. And one of the key messages here, purely with engine optimization, with hybridization, and also considering fossil LNG and LPG, most probably it will not be possible to achieve the future greenhouse gas reduction targets. So that means we will require new energy carrier in order to do that. And this is then also directly related to further questions, to further challenges. What about infrastructure? What about the energy storage also on board? What about a joint fuel strategy? And what also about costs, which are related to other alternative new energy carrier solutions? And one key message here, and we will also address that a bit more detail in the following slides, most probably there will not be the one and only strategy. There will be different technology strategies being needed depending on individual application type, maybe also depending on individual markets. Also taking the right application fit, the infrastructure availability, and also cost aspects into account. One important factor, I think, when we talk about alternative fuel, alternative energy carrier options is also the energy density. So on that slide here, we see the energy density on the one hand on a gravimetric basis, on the other hand on a volumetric basis for different energy carrier options. So on the one hand, if we compare liquid to gaseous fuels, there is some distinct difference, in particular if we talk about the volumetric energy density. So with quite some significant benefits for the liquid fuels. But also considering different liquid fuels, there are already some distinct differences here. So if we compare a conventional diesel fuel with methanol or ammonia, there is also already quite significant difference with regard to both volumetric and also the gravimetric energy density. And this even becomes more obvious and more challenging if we consider battery electric. So comparing the liquid and also the gaseous fuels with battery electric options, there is even an order of magnitude difference between the energy density of these energy carrier options. So what does that mean? That also probably means that full electric solutions cannot be the one and only solution, especially also if we consider applications which are typical for a medium speed engine application. Yes, there will be some selected use cases which are also really favored for battery electric solutions, and where we also see a lot of developments ongoing in the moment. Like for example, the ferries with quite predictable routes, super yacht applications, or also a tugboat, where also a hybridization from operation point perspective makes quite a lot of sense. On the other hand, also here with that slide, I think this is underlining, electricity alone for the applications which are typical for a medium speed engine. This probably will not be the one and only solution, or the solution just to a limited extent. So also here, the message, we need alternative fuel options. And if we talk about medium speed engines, especially also the liquid fuels, ammonia, also methanol, becoming quite interesting. So we talked quite a lot about marine, with that slide here, also just saying, of course, it's not just the marine sector. Also other industries which are relevant for large bore engines, which are relevant for medium speed engines, they also have according pressure to reduce CO2 emissions. It's a generator set, being used for peak shielding, also in combination with regenerative power, which will also in the future demand for low CO2, zero CO2 options. Also the data centers, also with a lot of pressure to become more green, to reduce their CO2 emission footprint, and also for power supplies in remote areas. Also in the future, more greener, low CO2 solutions will be required. And then last but not least, and with the following two slides, it's also already will be a bit the transition to the next presentation, going a bit more into details with regards to alternative fuel options. So what are the cons, what are the pros for the different fuel options here? And also here, not going into the detail, with the slide on the left-hand side, I think it becomes quite obvious if we consider different alternative fuel options, there are some specific pros and cons. So an LNG, LPG, has some distinct benefits, if it comes to the infrastructure, if it also comes to the cost perspective, the costs being to be invested, for the storage or also the powertrain itself. Whereas an ammonia, and also a hydrogen as an alternative fuel option have other benefits, with regard to sustainability, with regard to their greenhouse gas reduction potential, with regard to local emission potential, but with drawbacks, with regard to other perspectives. And now also again, being very, very important, in order to also conclude here that most probably there will not be the one and only solution. If on the other hand, we have look to the relevance of the different criteria, these different assessment criteria for the different application types, here we also have some distinct differences. So the relevance with regards to, for example, the storage density, the energy density of a fuel, this is different if we talk or if we consider a marine application or if we consider a generator set application. So again, the message here, no one-fits-all solution. You need to find the right solution for your specific use case. And this typically includes the question, what about sustainability? What about environmental friendliness, greenhouse gas emissions, also other pollutant emissions? What about the infrastructure? What about storage, onboard storage for all the different fuel options? And also, of course, very important for all the commercial applications. What about costs? The cost for the technology, the cost for the storage, the cost for the fuel itself. So this leads me to the end of my presentation, and also would be happy now to answer any questions from the audience.